Tuning in. Tuning in. Let's start off. So last thing we did was this. So let's see something similar like this. Hope everyone went through the notes once. It's important you go through the notes after every class. If you don't do that, everything will look like alien in the next class. It might look like, sir, every day karna hai. Trust me, it helps a lot. You might think you're wasting 15, 20 minutes, but that saves a lot of time. When you revise the book after a week, you will remember stuff. Or else everything will look totally new. Let's see. Let's do one problem before going ahead. We have a capacitor, we have a battery, voltage V, this is C. This guy has charge minus 2 CV and plus 2 CV. So you took a capacitor which already has some charge and you kept a battery and you closed the switch. Find the heat produced when switch is closed. Others, do keep your cams on. How to do this thing? We have a capacitor with minus 2 CV and 2 CV and we kept a battery there. Find the heat produced. Try. I'll give you a minute. Hope everyone is coming tomorrow 5 o'clock. So please make sure to be there. And dress code, you can wear whatever you're comfortable. Just don't wear anything too funky. Like don't wear a giraffe dress. Someone is planning to wear a burger cut dress and come. So don't. If you wear a tree cut dress and come, I'll punch you there only. If you wear burger dress, I'll tell everyone to eat you. So do come. And then come there tomorrow, right? Ekanksh is coming. Ekanksh is IIT Bombay, 49. And we have Anuj also, who's in IIT Delhi, right? I invited Shushruth also, who's from BITS. I mean, this year, people who got into IIT, right? Vivan is there, whose rank was 3,300, is getting IIT Bombay Civil. Pratishtha is coming. She's last year student. Her rank was around 9,000. So girl students, I tried my best to call as many of them as possible, but there are very few. I think only 2 will be coming tomorrow, I guess. So she got a rank of 9,000, but you can talk to her, like, how does it feel? Like I said, 20% reservation helps a lot for you guys. You should definitely take advantage of it. Right? There is one more student, Shivali Karke. She got into IIT Jodhpur. Her rank was 14,700. Right? But I don't think, she's not available. Exam ka hai. But around 10 to 11 seniors are coming. You can talk to them, interact with them. So the first reason why you're coming, let's be very clear, it is for food. That's the number one reason you should be coming for. If you're coming for anything else, then I'm going to punch you right and left. So eat very light dinner and come. The food is good only. I won't disappoint you there. 5 o'clock when you come, I told you, ma'am, make something good. So they're making 4 different sandwiches. I don't know what those are, but it should be good. It's a good hotel. I think it is 4-star. BBM says it is 5-star. So we decided it is 4.5 stars. So it is a good one. Food should be good only. And then second thing, interact with the people there. You guys also, right? See, it has been an online batch we have never met. So I also like to see you guys, how tall you are. Every time I see, I get surprised because on screens, I'm used to seeing you guys small, small, chota, chota. So in my mind, I always imagine you like, maybe second standard or third standard kids, I guess. That is the kind of imagination I have. And suddenly on that day, each of you will look like big, tall trees, and I feel like, what? So let's see. Why am I lagging? Am I lagging? Can you guys hear me?
Sir, hear but can't see.
Hello? Can someone hear me?
Yes, sir.
Yes, yes, sir.
Okay. So let's do this problem. I just restarted my router. This thing, whenever it rains, nowadays it is messing up a bit. Let's get this. Let's finish it off. We'll be finishing off with this and dielectric slabs today. We'll wrap up the chapter today. Next week we'll start off with current electricity. How do we start this? Is this router not getting connected today? So when you close the switch, how do we start this problem? Assume Q charge flows through the battery. That's how you always start. So if Q charge is flowing here, already how much charge is there? Minus 2 CV. So this will become Q minus 2 CV. And Q comes back to the battery, isn't it? Apply Kirchhoff's loop law in this. So we get V minus Q minus 2CV by C equal to 0. You come back to the same point. So we end up with CV minus Q plus 2CV is equal to 0. So Q is equal to 3CV. So this much charge flows through the battery. So what is the final charge on the capacitor? This is V. The final charge will be CV. This becomes a positive plate and this becomes a negative plate. What is the heat produced? Heat produced is initial energy plus work done by battery minus the final energy. What is the initial energy? Charge on the capacitor Q square by 2CV. 2CV by whole square by 2 into C. What is work done by battery? Charge flowing through the battery into voltage. What is the final energy? CV whole square by 2C. So simplify this. This turns out to be 2CV square. This would be 3CV square. This would be minus CV square by 2. 9 by 2 CV square. That's the heat produced. Check. I hope everyone understood how we got this formula here. Think of it like this. You have 100 rupees. Initially, you have some energy. The battery gave you 50. Finally, you have 20. Means what happened to the remaining? Isn't that heat? You have 100. I gave you 50. You're supposed to have 150. Why do you have only 20? Means you lost everything else. The rest of it is heat. Play with this. Have a look at this. So this is one important model. Let's see one more like this. Let's see. This is a good one. So we have a capacitor. We have one more capacitor. We have one more battery, and we have a switch. The voltage is V. This is C, and this is 2C. This is a positive plate plus CV. This is your positive plate plus 3CV. Now, if I close the switch, find the final charges on the capacitor. Find charges on capacitor and heat produced when switch is closed. So the capacitors are not empty, you already have some charge on them. Let's get this. How do we start? But again, the theme is always the same. Let Q charge flow from the battery. If there is no battery, Q charge flow from any one capacitor. That's how you always start. Anyone not coming tomorrow? Brinda, you can't come. I do understand. Anyone else? You should be there. Be there. Chalo. Abhiksha, you're coming, right? Why are you not coming, Abhiksha? Lol. I think Abhishek wanted to message someone else, I guess, and she messaged me. Or you want to message me on? Okay. Let's beat Shaurya tomorrow. We have a game, Hunt the Shaurya. I told you I am to hire some musicians, so we are arranging a musician also. He'll be there. When you also talk to seniors, for how long will you talk to them? 15, 20 minutes. After that, what you'll do? You'll be bored only. It's a decent place. You won't get to dance and all, but you can eat. It's a good place to walk around. You can walk, then come back, digest some food and eat again, and then walk and again come and eat again. So you can eat like that 3, 4 times. Last time when your seniors came, to we made sure everyone ate at least 4 times. Anyone who ate less than 4 times is executed. Dipanshu coming? Yes. Anamay, tomorrow you have to speak out. You can't be this silent. Kavya, you're coming? Kavya is going somewhere else. He's going to even better place with more food. And we do have Jain counter also. So if you're a Jain, don't worry. The chef will make 3 to 4 separate dishes for Jain people. It's arranged. How to do this thing? How do we start? Idea is the same thing. Let's start a Q charge from the battery. This guy was C and this guy was 2C. So let Q flow from here. So already, now understand here how much you have here. You have minus CV already here and minus 3CV here. So this will become Q minus CV. Sir, how do you know that's a positive plate? I don't know. I'll assume it's a positive plate and solve the problem. The sign will take care of it. This is Q. This thing is already 3CV here. So this will be Q plus 3CV. And Q comes back. I hope you're getting this logic. You don't get into the confusion in the exam or a positive, O negative. Don't do that. Unnecessary confusion. You just assume it is Q and start. Science will take care of it. Apply Kirchhoff's law. You're starting from there. V minus Q minus CV by C minus Q plus 3CV by 2C. You came back to the same point of 0. Hope you're getting it. Meaning you want, I can write this is A karke. So VA plus V and you come back to VA. The VA is cancelled anyway. That's the story there. Simplify. This will be CV minus Q plus CV minus Q by 2 minus 3CV by 2 is equal to 0. CV, 2CV, that will be CV by 2 is equal to 3Q by 2. Q is equal to CV by 3. So what are the final charges? V, and this final charges would be CV by 3 minus CV. So this is still negative plate, right? So this is plus 2 CV by 3. This is minus 2 CV by 3. And this guy would be CV by 3, 1 by 3 plus 3, 3 times CV by 3. This charge Q flows here. Now, important thing here. C and 2C are not in parallel, or not in series. Most people do this mistake. They think they both are in series. Tell me one thing. If two capacitors are in series, what is the condition they should satisfy?
Charge should be same.
They should have same charge. Do they have same charge? They're not in series. Just because they're side by side, don't assume they're in series. They should have same charge flow. That's a mistake most people do. Please have a look at this. I think once you got this thing, you're done. You can find the heat produced and the energy stored and everything. I'll leave that to you. But please check how I did this thing.
So means in a circuit like this for in series, it should be means same current was supposed to flow over.
Yeah. All got this thing. So the biggest mistake what people do, they think C and 2C are in series, but the catch is if the charge is not same, it is the other way around. Because the charge is same, you call it series. Not because it is series, charge will be same. Do have a look at this. Clear? Any doubts on this? So in Kirchhoff's law, this is another type of models, where the capacitors are already having some charge initially. Any doubts on this page? Please ask. Clear? Next one. Dielectric slabs. If you remember in the beginning, we made a statement like, to increase capacitance, you can increase area or you can decrease the distance, but both are not a good idea. So the third way, so normally you have vacuum in the middle. If you can introduce a medium in the middle, that will increase the capacitance. How is that? So if you take two parallel plates, and let's say if you fill up this space with the dielectric, dielectric slab is generally an insulator. Then your formula for capacitance becomes A into epsilon medium. Generally, it is for vacuum now by D. This can be written as A epsilon naught into epsilon R by D. So this epsilon R into capacitance in vacuum. If you remember, this epsilon R is what we call as dielectric constant. And for some reason in all the books, we write this as K. Dielectric constant. So this is also written as K. So in the entire chapter, we will call dielectric constant as K. So K is equal to 1 for vacuum. K tends to infinity for conductors. If you remember the definition of, the significance of dielectric constant is higher the dielectric constant, more difficult for the charge to flow. So if you have a more difficult for the field to flow. And if you have a conductor, the field that passes through is zero, isn't a shielding effect. A conductor will never let the field pass through it. So think of like this, a dielectric constant is nothing but resistance. How difficult it is for the field to go from one point to another point. Have a look at this. So this will be a new formula, everyone. If you put a dielectric slab in the middle, it becomes epsilon R into C vacuum.
So, but inside a conductor, it is like a vacuum only.
It's like a conductor vacuum is होगा. God, Shaurya, there are a lot of free electrons. Vacuum में कुछ है ही नहीं.
Okay.
Yeah. So what is exactly happening in a dielectric slab? Do have a look at this page. Ask me if you're confused. Next thing. Now, what is exactly happening? What is making the capacitance increase? Listen to this. And theory is important. The results are more important. Consider two parallel plates. With a dielectric slab between them. So what happens now? Unlike a conductor, where there are a lot of free electrons moving around, in a dielectric slab, you don't have enough free electrons, meaning the electrons cannot come out of the atom. So if you take a slab inside, you take a slab with a thin space. So what happens here is, this is positive. So you'll induce a positive charge here, plus Q. You have a negative charge here, minus Q. This plus charge will induce an opposite charge. So this will be minus, plus, minus, plus. You get dipoles. Unlike a conductor, where the electrons are completely removed from the atom, here the electrons can't come out of the atom. So instead they form dipoles. It's an insulator, right? In a dielectric slab, the concentration of free electrons is very less. What are free electrons? The electrons which can leave the atom. So when you say free electrons, these are the electrons which can leave the atom. In case of a conductor, you have a lot of them. So they easily move around. So because of this, what will happen? The electric field creates dipoles. Think of like this. If you have an atom like this, plus and an electron, if you apply an electric field like this, so on the positive charge, force will be this way. On the negative charge, force will be this way. So the atom will be split apart by separating the charges by a distance. I hope you're getting the logic here. So when you keep the dielectric between the plates, the electric field will push the nucleus and the electrons away from each other. So normally it should have been like this, right? A proper symmetry. But you start getting an elliptical kind of orbits. So this thing, isn't this what you do in covalent bond? If when you say HCl, what do you say? This becomes slightly delta negative, this becomes slightly delta plus because the charge got pushed towards the chlorine. Something similar happens here also. So we start getting dipoles inside a dielectric slab. Because of this dipoles, right, you start getting additional energy there. But let's see how to go from here. Have a look at this page. You know, in case of a conductor, what would have happened? If it had been a conductor, you would get all the charge here negative, all the charge here positive. In the center, everything is neutral. There would have been no charge in the middle. But dielectric में ऐसा नहीं है. You will find charge dipoles in the middle. हाँ, Shaurya.
So initially what we considered was मतलब ऐसा parallel plates के बीच में कोई कुछ भी medium वगैरह कुछ नहीं था.
Yeah, initially till we that only na vacuum. Okay. अभी तक we did always vacuum only. This is what happens if you introduce something between the plates. All clear with this? Please check. Kavish, clear na? Divyanshu, got
yes.
this? Dipanshu?
Yes.
Hasini, clear? Chirayu, Anamay? Vrinda, clear? Then, so if you put a dielectric slab like this, now listen carefully. So this is plus. And let's say this is sigma. Sigma is charge per unit area. This will be minus here. Minus sigma. Sigma is the surface charge density. Now because of this, you get a minus here. Now which will not be equal. This will be sigma induced. Remember, conductor it would have been equal. This is a dielectric slab. You won't get equal. This would be plus sigma I. So we get two kinds of fields here. One, due to the outside plates, you get a field here. And due to the induced charges, you get a counter field here, but it is not strong enough. In case of a conductor, both would have cancelled out. So field between the plates, field due to the induced. So even though the charges are not strong, they will still try to oppose and try to decrease the field between them. Field due to the induced charges opposes the field due to the plates. So if you look at here, the field due to the plates will be sigma by epsilon because there are two of them. Infinite sheet ka formula, everyone. The field due to the induced charge will be sigma induced by epsilon. Actually, it is sigma by 2 epsilon. There are two plates. And we know from Coulomb's law. Do you guys remember Coulomb's law? If the force between two charges is F, force on each charge. If you put them in a medium, what is the force on each charge?
It is still F only between those charges.
No. Force on
F
each
by
charge.
dielectric constant of medium.
Force on each charge, that will become F by K. Between them will remain same. On each charge, it will change. From Coulomb's law, the field inside becomes 1 by k times outside. That means if you have a dielectric slab here, if the field outside is E, the field inside should be E by K. Is that making sense? Once you come out, again it will become E only. So E inside is nothing but E plates minus E induced. So E inside is E by K. E plates is sigma. E plates is inside is E plate by K. This is E plate minus E induced. So if you substitute the formulas, we get sigma by K epsilon is equal to sigma by epsilon minus sigma induced by epsilon. We get a pretty good result. We get sigma induced is equal to minus sigma into 1 minus 1 by K. You definitely need to mug up this result. So whenever you put a dielectric slab in front of a conducting plate, it won't be equal and opposite charge. It would be sigma into 1 minus 1 by K. Let me show it on the next page in more detail, but have a look at this, what I did. So from Coulomb's law, we know the field inside becomes 1 by K. Why did it decrease? Because the induced charges are opposing the outside field, both will subtract each other and it will decrease. So E plates minus E induced should be equal to E plate by K. So from there, I can find the induced charge. And you can ask pretty good questions on this, which are little non-standard. I'll show you them. And the questions will look quite similar to heat transfer ka questions. There K was thermal conductivity, here K is dielectric constant. Uske alawa everything else is same. The formulas are different, but yeah, the idea is the same.
Sir, E plate will always be greater.
E plate will be always greater.
Sir, inside the induced charges also you told कि मतलब सर दो surfaces बनेंगे ना इसलिए sigma.
Do have a look at this video. Clear? So let me just generalize this, what is happening. That means so if you take a dielectric slab K, so on this charge, if you have charge Q, this is minus Q. Here you will get a minus charge, but this will be Q induced. And this will be plus, which is plus Q induced. So we get the Q induced charge will be Q into 1 minus 1 by K. For conductors, K is infinity. So in that case, Q induced becomes equal to Q now. Isn't that what we proved in Gauss law? For a conductor, you induce equal and opposite charges. So exam equation case hoga. We have a plate. Let's say this charge is 2Q and this charge is, this is neutral. Both are conductors. Conductor. You can actually do this as a question only, but okay. Day one. Same question, but this time, let's say we have a plate and we have a plate. This time, this is a conductor. But this is K is equal to 2, dielectric slab. And this charge is plus 2Q. This is neutral anyway, dielectric has no charge. Find the charge distributions and the force between them. Find the charge distribution and force between the plates. This is a dielectric plate. The first one is basic Gauss law. Second one is a little different. Try. I'll give 2-3 minutes. Think about it. This is a non-standard question. ऐसा question अभी तक पूछा नहीं. Conducting plates and dielectric slabs. But there, this is the result here. So Q induced. You can also write in terms of sigma induced. It's the same thing. Q by area becomes sigma.
तो कंडक्टर के केस में साथ टोटल बाय 2 हम लगा सकते हैं.
Yeah, वो लॉजिक तो अभी भी वैलिड है. Show you the first one. First one, see. Conductor, conductor. So the charge was 2Q. How is the charge distribution? Outside is total by 2. So how much is this? Q, Q. So this should be Q. This should be minus Q.
Minus.
What is the force between the plates? Remember, force is only due to the inside charges. Because this conductor is like a shielding, the outside charges won't matter. Force is due to inside charges. How do we find that? The force formula tha directly Q square by thing, but let me show you that. The force on left plate or right plate will be field due to left plate into charge. The field due to left plate will be sigma by 2 epsilon into charge will be minus Q. So minus Q square by 2a epsilon. Because sigma is Q by area. Got this? This is the same formula which we got force between the plates. Look at this guy now. How much is K? 2, no? So if you look at the distribution here, how much you get here? This would be 2Q and 0. This will be Q and Q. Now the difference would be this would be Q induced. And this will be plus Q induced. So Q induced will be Q into 1 minus 1 by K. So this is actually Q by 2. Charges won't be equal and opposite. It will induce only half of the charge. The force between the plates will be Same formula, sigma by 2 epsilon into minus qi. So that would be q by 2a epsilon minus, and this is again another q by 2 minus q square by 4a epsilon. Force becomes half of it. Are you getting this, the difference? Because of symmetry, it will induce equal charge q and q, and then you just have to find the induced charge and finish it off. This is how you do if a dielectric slab is given. This is a totally different model. Conductors, you already know how to do, but with a slab, this is what you do.
सर फोर्स ऑन लेफ्ट प्लेट निकालते तभी तो चार्ज हम लोग क्यों लेते
Same
पता लगा
आएगा. Then you take q का field ले लो. You have to take the field due to this guy and multiply with
Okay.
this charge. Same तो आएगा ना शौर्य.
बताओ
Clear with this? Please check. All got this? Next thing. Next one. Now, this is our standard questions. These things will look exactly like, heat transfer questions. Let's say we have a dielectric slab. The area is A. D by 2. D by 2. So you're filling this side with dielectric constant K, and you're filling this side with dielectric constant 2K. Remember this thing, heat transfer में क्या था? There it was thermal conductivity. Find C equivalent. So left half is filled with K and right half is filled with 2K. Find the capacitance of this system. Area of the plates is A and distance is D. Get this. Exact same things we have done in heat transfer. They gave us thermal conductivity and asked you for thermal resistance. Everyone should try. Hasani, give it a try. Don't wait for me to write the answers. If you just listen like a movie theater, you will not learn anything, everyone. Try. It's okay if you don't get it, but give it a try. Think whatever you can do for a minute or two. That's what you are there for. Once you start doing that, things will start, it might not click now, but when you're solving at home, when you're practicing, it will click because you tried now. If you think I'll just stare, I will listen, practice करते समय somehow आ जाएगा, नहीं होगा ऐसा. The amount of struggle you need to do to solve a problem is fixed. If you struggle in the class with me, I'm there to help you, so it will be more easy. So don't struggle on your own. Let me help you out. Try. Someone got an answer. Kavish. Let's see. How do you proceed with this? I'll just help you out. So this is what I can do now. I can divide this into two capacitors. The left half is filled with K. The right half is filled with the green one, 2K. Area of the plates will be same area, but the distance becomes D by 2. D by 2. So this capacitance C1 is area epsilon by D by 2. Dielectric constant is K. This capacitance is C by 2, A epsilon, D by 2, dielectric constant is 2K. Both the capacitors are in series. So C equivalent will be C1, C2 by C1 plus C2. Easy? You just treat them as two different capacitors and solve. I'll leave the solving to you. Please check. This is how you separate into. Clear? Next one. Next one. What if we divide like this? The upper half is filled with K. The lower half is filled with 2K. The distance is D. So basically now the area becomes A by 2 and A by 2. Now find C equivalent. Now get this. Ideas are exactly same as heat transfer. Try. You got a minute. Let's finish off. So we can write this thing as capacitor. They're in parallel. Same potential difference. So this is K. This is 2K. C1 and C2. So C1 will be area has become of A by 2 epsilon by D into K. C2 is A by 2 epsilon 2K by D. And C equivalent is C1 plus C2. Easy? Nachrayu, clear so far? Divyanshu, clear? Great. Please check. Anyone has a doubt on this, ask me. Nishita, got it, no? This is a good one. What if the left half is filled with K? This right side ka upper half is filled with 2K. This is 3K.
Oh, sir, now we have to divide that K into K and K, na?
Karo. I taught you this is a very important model. Most people goof up this thing. Iska kya hoga? Try. So the left half is filled with K and the right half ka up is filled with 2K and bottom is filled with 3K. Total 3 different materials. Get it. You got 2 minutes. Find the C equivalent of this.
So can we show the previous questions? Yes, sir.
See, the main idea in this thing now, if you do like this, means you take the K as one capacitor. And if you take 2K and 3K as one capacitor, this is wrong. Be careful. This is wrong. Don't do this. Reason, if you look at this region here and this region here, the upper half and the lower half are not identical. So if they're not identical, that means here the potential is V1, here the potential is V2. So is the potential difference same? Potential difference is not same. So what is parallel? If the potential difference is same, they're called in parallel. Just because you're side by side doesn't mean you're parallel. Are you getting this? So since the upper half and the lower half are not identical, you can't take 2K and 3K in parallel. Since upper and lower half are not identical, the interface will have different potential. If the interface has different potential difference is not same. Therefore, 2K and 3K are not in parallel. Then how do you proceed from there? So you have to split that K into two pieces. So you split K into two pieces, K, because K and 2K are in series, K and 3K are in series, up and bottom are in parallel. This is 2K, and this is 3K. So we can write simply C is equal to, area becomes half, epsilon D by 2. So C is A epsilon by D. So this circuit simply becomes Kc, 2Kc, Kc, and 3Kc. The upper two are in series, and both are in parallel. Clear? And this thing comes out to be how much you're getting? 12 by 7 A epsilon by D into K. I think that's what Harsh wrote. I don't know whether that is the answer. Others can check and see whether that's the answer.
17 by 12 आ रहा है 17 by 12
17 by 12 आ रहा है
17 by 12 it is there. That is the answer if you solve. Please check it out. Quite an important model. This is the second time you're encountering this after heat transfer. Most common mistake, people think 2K and 3K are in parallel. That is wrong. Kavish, check where you went wrong.
Or I didn't understand why that isn't in.
Which one?
Why didn't we take it in parallel?
Abhi story to itna wahi hai na. But to be in parallel, what is the condition?
Potential difference.
So this is different and this is different. Do you agree?
Oh.
Agreed with that? Sure.
Yeah.
So agar ye VB liya, so this potential difference and this potential, will it be same?
No.
Then they're not in parallel. Got it? Just because they look side by side, na lagta hai parallel hai. You don't go by looks. See, actually, is it same? You should always see, like, in this question now, why didn't we take these two in series then? In this case, why didn't we take them in series?
Because the charge was in.
Charge is not same. So the definition is that way, because if the charge is same, they're in series. If the potential difference is same, they're in parallel. Please check everyone. Have a look at this. It's a good one. Clear na, Arushi? Got this? Kavya, Brinda, clear? Reina? Clear na? Trisha? Check. Chirayu, do keep your cam on. Divyanshu, keep your cams on, everyone.
Yes, give me one.
Clear? Next one. what if you have a parallel plates like this? Area is A, but you have only a slab somewhere in the middle like this. Slab ka thickness is T. The total distance is D, and this is X. This dielectric constant is K, and this space is vacuum. Are you getting how it is? So you introduce the dielectric slab, completely it is not filled, only a part of it is filled. Find C equivalent. How do we do this? You can treat them as three capacitors, no? Capacitor, capacitor, and capacitor. This capacitor is X. This capacitor is T, which is filled with a slab. This is again D minus T minus X. Make sense? And all three are in series. So 1 by C equivalent is 1 by C1 plus 1 by C2 plus 1 by C3. So C1 is nothing but A epsilon by X. This is A epsilon, dielectric constant is K, this is T. This is A epsilon by D minus T minus X. When you add them, X actually cancels out. We get D minus T plus T by K, 1 by A epsilon. So C equivalent is simply reverse this. You end up with A epsilon by D minus T plus T by K. And the best part about this, it is independent of X, means no matter where you keep the slab, the answer remains same. Whether you keep the slab in the middle, close to one plate, anywhere you keep, the answer won't change. So whenever you get problems like this, you can just push the slab to one side and you can treat the D minus T as vacuum and solve the problem. Instead of taking three capacitors, you could have just made with two capacitors. Check. Clear with this? Any doubts on this? Krishna, clear, na? Arushi? Harsh, clear. Kavish, got this. Nanya? Can I go ahead? Next one. So this is all one type of problems, more like heat transfer. If I have to ask you something more better, what if we have two square plates? This is a question from HCV. Side A. This lower half is filled with a dielectric slab, K. And this half is filled with 2K. You're getting how it is like a sandwich cross. The distance between the plates is D. The side of this thing is A. So you're connecting the battery between the upper and the lower part. Find C equivalent. How do you do this?
Sir, symmetry है क्या diagonal के?
क्या symmetry है? Circuit नहीं है शौर्य ये.
Okay.
You have to integrate. There's an integration involved. Think 2 minutes. Just give it a try. I get some water and come. Let's see. How do you proceed? इतना chance रह गया हर्ष. So listen. I'll give you a hint, then I'll give you a minute. Try about it. See what you do now. At a distance x, take a small dx. So when you take this plate, this is how it looks. So this side is A and this width is dx. Within this, let this angle be theta, where tan theta is equal to opposite side by adjacent side d by A. So you can treat this part as one capacitor DC1, and you can treat this capacitor as DC2. Agreed? So this whole setup becomes as if there's one capacitor DC1 and there is another capacitor DC2, and both are in series because same charge will flow. And these sections are in parallel, isn't it? Because all have same potential difference. Is that making sense? And what will be this length here? This length will be, if this is x and this is theta, this length will be x tan theta. And this length will be d minus x tan theta. And this area will be A into dx. Try from here how to do. Think I'll give another minute or two. This is how you choose an element. You take a thin strip, you take the upper and the lower are in series, and this entire section is in parallel with everyone. How do you proceed with this? So DC1 will be area, which is A into dx. Epsilon, dielectric constant will be 2k by distance is d minus x tan theta. DC2 will be A dx. Epsilon k by x tan theta. Both are in series. So 1 by DC is 1 by DC1 plus 1 by DC2. So reverse and add them. If you take out that 1 by A epsilon k dx common, you end up with d minus x tan theta by 2 plus x tan theta. This is d plus x tan theta by 2a epsilon k dx. This is 1 by dc. All are in series. So C equivalent will be integral dc. That would be 2a epsilon k integral dx by d plus x tan theta. X का value from 0 to a. This is nothing but ln ax plus tan theta. So 2a epsilon k by tan theta. This will be ln d plus x tan theta. Limits will go from 0 to a. So C equivalent will be 2a epsilon k, and tan theta is nothing but d by a. This will be ln d plus x tan theta. Put the limits. D plus a tan theta by d. This will be 2a square epsilon k by d. That will be tan theta is again d by a. So that is ln 2. Check the steps here. Once you got this, it's just a matter of substituting. That's how you do that. Do have a look at the steps.
Sir, we could not have divided these two capacitors in like triangles, no?
Triangle capacitor का formula क्या है ऋषि?
नहीं है. Because like I started with triangles पहले integration.
Rectangle slabs का formula हमको पता है. Triangle का formula कहाँ पे है? हमने derive ही नहीं किया. There are three types of capacitors ना. Parallel, cylindrical, spherical. Triangle capacitor कहाँ पे है?
I did think about that.
तो create किया है तो नया capacitor.
I did started with the ratios and all. वो double variable kind integration.
Happens. Have a look at this, everyone. Clear? Next thing. This is a good one. Right? Standard question. Let's see how many of you remember this. We have a capacitor with a battery. Case 1, battery is removed. Remember, we did this before. The distance between the plates is doubled. Case 1, battery is removed. Case 2, battery is present. And then a dielectric slab K is introduced between them. So you removed the battery and you kept a dielectric plate between them, dielectric slab. If you remember the previous question, there the distance between the blades was doubled. Then what I want you to find the new charge, the new capacitance, new potential, new energy, new field. Same question, new force, new energy density. Exam they can ask any one. For case 1 and case 2. Let's do this. Think for a minute, then I'll show you case 1, then you can do case 2. Yeah, if you remove the battery, remember charge will remain same. If you keep the battery, potential will remain same. See, let me show you one. Let's do case 2. So when you remove this, the charge will remain same. So plus Q minus Q. Charge won't change. So Q is CV. And you introduced a slab between them. So Q remains same. You have same charge. So Q will be Q only. What will happen to capacitance? K times C. And we know Q is equal to CV. If so V is Q by C. So this will become 1 by K times V by K. What about energy? Energy ka formula is Q square by 2C. So C became K times. So energy becomes 1 by K times. Field is potential difference by distance. Potential difference became 1 by K times. So field also becomes 1 by K times. Force is Q square by 2A epsilon. This is the force between the plates. It will remain same. Q didn't change, no? What is energy density? Half epsilon E square. The field became 1 by K times. So now here, be careful. Two things happen here. No? Half epsilon E square. This becomes K times epsilon. This becomes E by K. Isn't it? Epsilon also will change here, no? तभी कितना होगा ये? K into this thing. This becomes 1 by K times. Please check. See what we did here. If you remove the battery, the charge remains constant. If you keep the battery, potential remains constant. Can you do the case 2 now? Case 2, battery is there and you kept a slab. Do have a look at case 1. Any doubts on case 1, please ask. You're clear with this, go ahead with case 2. Anyone confused with this? Not clear? Please ask, don't hesitate, get it clear. Kavish, getting it so far? Nishita, Divanshu, Amazon, ask me if you're confused.
Or in this case, for force, that epsilon naught is also changing.
No, this is the force between the plates. Na? If you put K, it will become force on each plate.
Okay.
Yeah, like because remember when you write force between the plates, what is the formula we write? Field due to one plate into the charge on the other plate. The field due to one plate will never change. So that epsilon won't get affected actually. Actually, no, formula wrong. I shouldn't have written like that. So actually, you can say like this: the formula is derived after taking K into account. That is only epsilon naught. Okay. Look at case 2, everyone. So in this case, we have same voltage. So voltage will remain same, V. Capacitance becomes Kc. Charge becomes Kq. Energy is half CV square. So this becomes K times. Field will be V by D, same. Force will become K square times. Energy density would be K times because this is half epsilon E square. E is same, but epsilon has become this thing K times. Check. Yep. Clear? Okay, which one? Field? Which one, Hasni, you're talking?
The energy is K times, so energy density should be k cube, no?
Energy is k times energy density should be k times. Yeah. वही लिखा ना k times.
तो k cube नहीं होगा.
Cube. नहीं. It is half epsilon e square ना रे. Field देखना but this E is not energy. ये field है.
Ah, okay, so yeah.
That is field. All got this? Then. We have a small concept here. Force on a dielectric slab. This is the last concept. So what happens if you have a dielectric slab? Think like this. So battery B, these are plates, square plates of side A. So what actually happens, right? So when you keep this charge plus and minus, you get a plus here. And you get a minus here. So on the edges, the field is not actually proper. It is not straight. In the center, the field is like this, but the edges, the field is actually kind of like this, the fringe effect. So in this scenario, if you take, let's say, a slab, and if you try to bring a dielectric slab here, observe how will the force be here. This will have already some negative charge here. This will have some plus charge here. This is plus. This is minus. So because of this fringe field, this is a negative charge here. The force will be this way. This is the positive. The force will be this way. Can you see how it is? The force will be along the field. So if you look at this dielectric slab, the force on them will be like this. The negative is getting attracted this way. The positive is repelled this way. The resultant will be inside, na? You getting this? So that means if you take a dielectric capacitor and if you try to put the slab little close, it will get pulled inside. You getting this? So a slab, a dielectric slab placed near the opening of the capacitor will be pulled inside. Near the end of the capacitor, plates will be pulled inside. There's actually the slab gets attracted. Please check out this logic. So this happens only on the edge because center में problem नहीं है. Center में what will happen? Once the plate has gone inside, this will pull up, this will pull down, they'll cancel. Na? There you won't have a problem. Problem is only when you're outside. Please check this logic here. So then how do we calculate this? So this is what we do. So let's say this is a square plate. This is an important formula you need to remember. Side A. So this is A. This is the distance D between them. This is also A. And let's say you introduced a slab till here. Let the slab be X inside. Means the balance distance will be A minus X. You're getting it? So let's say the slab has gone X inside. Let the slab Bx inside. So now you can treat this as two capacitors. So you have one capacitor filling up this gap up to x, and we have one vacuum capacitor with a d minus x. Are these two capacitors are in series or parallel? The red one, the
Parallel.
vacuum one, parallel, no? Because they have same potential difference, isn't it? So we can write them as C equivalent. Now look at the areas here. So this area will be, this is A, and that is d minus x. So A into A minus x into epsilon by d plus A into x into epsilon into k times by d. So from here we get the capacitance A epsilon by d is equal to A minus x plus kx. This is the capacitance of the circuit as function of x. As the slab goes inside more and more, the capacitance will actually increase even more. Others, do keep your cams on. Arushi, Anamai, Chirayu, Divyanshu, Rena, Shaurya, cams on. So from here, we can find the energy stored is nothing but half C equivalent into V square. This is half A epsilon dV square into x into k minus 1 plus A. Is there any relation between force and energy? Force and potential energy, what's the relation? Force
Minus
is
du
given
by
by
dx.
minus du by dx. So अगर इसको differentiate करेंगे, you get A epsilon V square by 2d with a minus sign into k minus 1, which is a constant there. This is the force that is acting on the slab. And remember, this is a constant force. Huh? Doesn't matter how much it is inside. It is little inside or half of it is inside, the answer is same. Independent of x. That was a surprising thing. I'll write down the result on the next page. Quite an important result. You need to literally mug it up. Do have a look at this step by step how I did this. Clear? There, let me write down that result. So this will be pulled inside with a force F. F is equal to minus A epsilon V square by 2d into k minus 1. Perfect. That's the negative force of attraction. So you know how they can ask questions on this? They'll simply say there's a plate like this, there is a slab like this. This side you have a pulley here and you attach to a block M. And they'll ask you find the voltage of the battery if the system is at rest. What should you do? This is force F now. F should be equal to mg. straightforward there. Getting it? They can even ask you something of this sort. Find the time period of oscillation. So if you leave this thing, what will happen? It will start oscillating inside and outside, right? So this is one formula there. I can also ask you a question like this sort. Same thing, if you take these two parallel plates and if you put them on top of a liquid, density rho and dielectric constant K. Can you tell me what will happen? If you have a dielectric liquid and if you put these two plates just on top of the liquid.
Capillary action.
Capillary, ignore capillary, what will happen? Plates are just placed above the liquid.
Liquid will move into
Liquid will
the
get attracted,
empty
na?
space.
Yeah, liquid will get
Of course.
attracted. It will get pulled up inside. Plates are
It will have its
fluid in an
own
empty-
weight. So
Yeah. Let's do that question. So we have two capacitor plates. Area A, distance is d between them. You connected this with a battery. The plates are looking weird. There is a liquid here at the bottom. Density of the liquid is rho. And K is the dielectric constant. Battery ka voltage is V. Distance between the plates is D. This is a square plate of side. These are square plates. Side. Find the height of the liquid column that rises between the plates. So when you keep them near the liquid, liquid will get pulled inside. Neglect capillary action. You can also include surface tension also. That will be one more additional force to solve. How do you do this? So you should know this formula. In case you didn't write, put it down. Okay, let's see. Let's see. Try. I'll give you a minute more. So when you take this parallel plates, let's say the liquid has gone up till here. Who is pulling it? The dielectric slab ka force, isn't it? So the force acting is up F, and the weight is acting down. So let this height be H. This area is A, side is A, and this width is D. So F is equal to mg. F is A epsilon V square by 2D into K minus 1. Mg is how much? Density. It's a cuboid there. So height H, A, D by G. Oh, yeah, you'll get H from here. A will get cancelled. You end up with epsilon V square by K minus 1 by 2D square rho G. Check. Easy. The force of attraction will be equal to the weight of the liquid that has gone up between the plates. Everyone clear with this? So that formula is important. Do mark it up. You get straightforward questions on that. One last thing in this. So when you have taken this, so we can write force is equal to mass into acceleration. So we get acceleration will be that F by m A epsilon V square K minus 1 by 2md. Do you observe acceleration is constant? So what will happen to this motion here? Look at the diagram here. T0, you look like this. And don't forget this distance is A. Using the equation S is equal to ut plus half at square, we get A is equal to half into acceleration into time square. So from there we get the time 2A by capital A ka root. This is the time taken to enter inside. So this will be, so let's call this capital T. If we take T is equal to T, what will happen? The slab would completely enter inside. If we take T is equal to 2T, T is equal to 3T, and T is equal to 4T. This is how the diagram looks. At T is equal to T, the slab has completely gone inside. At T is equal to T, the slab has come outside, but the force is again inside. Then again, it has gone completely inside, mean position, and then again, finally, it is outside. So what's the time period of the motion? 4T. What kind of motion is this? What kind of
Periodic.
motion is this? Periodic. This is not SHM. Be careful. SHM force should be proportional to X. Na? This is independent. Force is constant. So this will be periodic motion independent of X. Don't forget this. A dielectric slab placed near the capacitor plates will be execute a periodic motion. And the time period will be 4 times this capital T. Most common mistake people do, they think it's SHM. Just because everything oscillates, SHM nahi hai. Clear? Do have a look at this. There. With that, we're done with the capacitors. So the dielectric slabs is one important part. So we'll wrap up with this thing for today. Tomorrow we are meeting at 5 o'clock. So make sure to come there. And so tomorrow, obviously, we won't have a class then. And then we'll catch up again on Wednesday directly. Wednesday, Saturday, and Sunday next week. We'll start off with current electricity. We'll be starting with a new topic, current. So capacitors is done. So try to finish off capacitor solving by next Saturday. We have 1 week time. It's an important chapter. Do go through the circuits and everything. We did around 35 questions. I think HCV has around 50, I guess. So you'll be able to handle it. So do finish it off. Those who have any doubts, please stay back and ask. Also free to leave. I'll see you tomorrow at 5 o'clock. So take care, stay safe, and do start solving. And the paper is online till Tuesday night. So make sure to get.